Let's look at some substitution by integration problems. So let's say we have the integral of x over the square root of x squared plus 5 dx. Certainly looks like that I should let that be my inside. So u equals x squared plus 5. When I take the derivative, I get 2x dx. And it looks like I just have an x dx. I don't have a 2. No problem. Divide 2 on both sides. And I get exactly the leftover, the x dx. So we get this becomes 1 over the square root of u. And then the 1/2 du gets substituted. All right, so I have 1/2. I'm going to turn this into u to the 1/2, and then I'm going to bring it to the top, so that becomes u to the negative 1/2. And now I finally have it in the form that I can actually take the antiderivative by doing u to the negative 1/2 plus 1 over negative 1/2 plus 1. So that gives me 1/2. The top, the 1 is actually 2 over 2. So that would be 2 over 2 minus 1/2, which would be the 1/2. The bottom becomes the 1/2. And remember, when you divide fractions, you flip and multiply. So I'm going to flip that. So I don't know why I did that symbol. Make it go away. So I have the first 1/2 out front, and now I'm going to flip the 1/2 on the bottom, so that becomes 2 over 1. I get u to the 1/2, and of course all that stuff cancels, so I just simply have u to the 1/2, but I need to plug back in what was u, which was x squared plus 5, and the 1/2 is the same as the square root, of course, plus c, and that gives me my answer. Okay, so let's find another one here. If I have, if I have something like the integral of x times the square root of 2x squared plus 11 dx. Once again, kind of the key here is to see that you have one function being multiplied by another. Again, definitely looks like the inside would be my u. So u equals 2x squared plus 11. I find that derivative, which would be 4x dx. I see an x dx, but I don't see a 4. So let's divide that off. I get 1/4 du equals x dx. So back over here where I see my square root under it, I put a u. Where I see x dx, I'm going to put a 1/4 du. And now, oops, I'm ready to put my 1/4 back in there. I'm ready to find my antiderivative, so I do that to the 1/2 power. So I get u to the 1/2 plus 1 over 1/2 plus 1. That's going to give me u to the 3/2, because 1 would be 2 over 2. 3/2, 3/2. Just like I did on the last one, I'm going to flip the denominator fraction. And so u to the 3/2, 2 goes into 4 2 times. So that would be 1/6, and then u is 2x squared plus 11, and then finally to the 3/2 power. So once you get going on these, I think you'll see you just do the same thing over and over and over. Find the u, find the du, do all the good substitution and all that good stuff.